Problem 2, using the vertical motion model, and that's this equation up here. During a halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial velocity of 72 feet per second. Now that's the initial velocity. Obviously it's going to kind of slow down. The t-shirt is caught 35 feet above the court. Okay, so maybe somebody up here, who knows, right? But they're 35 feet up. How long is it going to take the t-shirt to reach its maximum height? So we're saying like it's going to go, if you could see it sideways, it's going to start here, it's going to go up, and then somebody's going to catch it before it lands back on the ground. They're saying, what's the maximum height that it's going to reach? And what is the range? Well, I want you to think about this thing. Let's draw it over here so we can actually see it. Alright, here it is. It's starting. And remember, it's starting, if you look at the picture, it's starting 5 feet above the ground. Okay, so here's the ground. Starting 5 feet above the ground. And they take it off the slingshot and they whirl it up, up, and then somebody catches it at 35 feet before it has any time to go back down. Okay? They're asking us what's the maximum, and they're also asking us how long is it going to take the t-shirt to get there. Here's the maximum, and how long is it going to take for the t-shirt to get to the maximum. Well, guys, anytime, take a look at this. Pretend that you extended this parabola through. Can you see how it would make a final U as it traveled down? Can you see that? It's making a U shape. All right. I want you to think of another word for this maximum point. Think about what we call any maximum of any parabola. I hope that you're thinking that it's called the vertex, because it is. The vertex of our parabola is the maximum. Well, it's a good thing I taught you how to solve for vertex, isn't it? So let's write this down. Solve for vertex. Well, you're used to having x and y, right? Well, let's just stick with that for a second. We have x equals negative b over 2a, right? Isn't that how we start for our vertex? So that's going to be x equals, now maybe it would be important for us to make our equation. Let's make our equation down here. From this little tidbit up here, we know that height is based on, so h equals the pull of gravity, negative 16, t squared, plus, now what is the initial velocity? Read through the problem. You should find that the initial velocity is 72. So we replaced the letter v with 72 because that was the initial velocity up. If it was thrown down, you would make it a negative 72, but it's thrown up. Now what's the plus c? Plus c is the initial height. What is the initial height? 5 feet above the ground. So here's our equation. Now we can go back and figure out negative b over 2a. Now let's look at this. What letter did t replace? Think about all of our equations. Didn't t replace the letter x? So how about here, instead of writing x equals, we write t equals. Now you know you're solving for time. Opposite b is negative 72 over 2 times a. A is negative 16. So that's really negative 72 over positive 32, or excuse me, over negative 32. So negative 72 over negative 32, what does that equal? Time equals 2.25, and this is all measured in seconds. Well, that's how long it's going to take it to reach the max. Now let's figure out how tall it will get. Well, since that's the time, let's write that down. Time at max height. Since that's the time, all we have to do is plug it in. So if we're trying to find the max height, we're going to do h equals negative 16 times 2.25 squared. I'm plugging it in for t, plus 72 times 2.25, plus the last 5 that we had. Multiply all of these items together, get a final answer of 86. Height is measured in feet. Now let's get a nice therefore statement. Therefore, the maximum height is 86 feet, and it reaches this at 2.25 seconds. We have one more question. It says, what is the range? Alright, let's talk about the range. Remember, the range are like the y values. Those are your up and down values. Well, let's talk about the lowest that it goes. What is the lowest? And that's why I think sometimes the picture is so helpful. Where is the lowest height that the t-shirt ever was? Well, that's pretty easy if we look at our graph. The lowest is 5. Now, what is the highest? Well, we just solved for the highest, didn't we? The highest it ever reaches is 86 feet. So there is your range. Got it? In problem 2, suppose a t-shirt is launched with an upward velocity of 64, but it's still caught at 35. How long will it take the t-shirt to reach its maximum? How far above the court will it be? What is the range? We're going to practice this one more time, exact same type of problem, but this time it's not going to be thrown. See the 64? It's not thrown as fast. This time it's not launched. Maybe that would be a better word. It's not launched as fast. So we're going to keep h equals negative 16 t squared. But instead of plus 72, this time we do plus 64t. Plus, well, how high was it off the court? It was 5 feet. Okay, we're going to suppose that it's the exact same. So, if we're trying to find the max, you have to find the vertex. The vertex is t equals negative b over 2a. That is negative 64 over 2 times negative 16. That's negative 64 over 2 times negative 16. So that's a positive 2. Now what does that mean? That means it takes 2 seconds to reach max, because we solved for t. Now how do we find the max? We plug it in. Negative 16 times 2 squared plus 64 times 2 plus 5. Negative 16 times 2 squared plus 64 times 2 plus 5 is 69 feet. So it takes 2 seconds to reach 69 feet. Let's talk about the range. If you're a visual learner like I am, here's the court. Here's where it starts. It goes up and it's caught. It starts at 5 feet. Way up here it reaches its max. What did we figure out? 69. It's caught at 35. So the range is 5 to 69. Shortest to tallest. If you want to do any of these for extra help, go ahead and get them checked with me, and I will see you tomorrow.